Sorry.
It
Yes.
should be, yeah. Yeah, so
Okay.
we have our meeting scheduled for Wednesday.
Okay. Okay. Well, welcome to the June 22nd, 2021 session of Tangerine SDR and HamSci technical session. My name is Dave, KV0S, and this week I've been working with Kong and been working with Bill and Tom on different aspects of the radio. Um, Still lots of little details to work out. Big picture, we have it pretty well in place. Details, we still have plenty of things to work on. That's about it for me. Next on the list, I have Nathaniel, W2NAF. Go ahead, Nathaniel.
Thank you very much. I've continued working with my students this week. This week is the CDR conference, so I'm actually giving a talk tomorrow with an update on the personal space weather station. So maybe during the open session, we can have some people, especially Scotty and you, the magnetometer people, look at my slides and make sure they're up to date. And I think that's about it. W2NF, back to Nat.
Well, fine business. Next on the list, we have Dan in for XWE. Go ahead, Dan.
Okay. Alrighty.
Are you going to show something?
No. I'm going to try to get to the screen that has the video on it. So, okay, sorry about that. You caught me by surprise. I didn't expect to be called on so quickly.
It's random. It turns out to be by the order of the first name.
Okay, so I missed last week. Unfortunately, I was working, believe it or not. We're doing a lot of instrument training right now, and the best time to do it's at night. So I've been out to a lot of evenings lately, and sometimes up till 2 or 3 o'clock in the morning. So anyway, I've been working a little bit with WSJTX and the Raspberry Pi, and I have scripts for installing WSJTX, the latest version 2.4. Well, it's actually not the latest, it's the latest stable 2.4.0, and also Pi HPSDR, or whatever you want to use to control your radio. And it works really well. Haven't done much other than that. That's kind of been about it. I have updated a bunch of scripts to the latest version of software. They're available on GitHub/my call sign if anybody wants to take a look at them. They all seem to work well. They're well documented. So if you want to learn a little bit about writing scripts, it's not a bad tool for that. So back to you, Dave.
Fine business. And I'm not sure, have I linked that on TangerineSDR?
I don't think so.
I will link your GitHub.
Okay. Yeah, I've got scripts for about 25 different packages. Well, I should say 25 different versions spread around about 6 or 7 different packages.
Okay.
Some of them are for the Odroid N2. Some of them are for the Raspberry Pi running the Raspberry Pi OS, and some of them are for the Raspberry Pi running Ubuntu Mate.
Okay. Well, very good. Next on the list, I have Dave, KD0EAG. Go ahead, Dave.
Well, hello. I've been doing stuff. There was something last week, but now I forget. But the last few days I've been working on trying to make better data presentation and data, and some modifications to the RunMag stuff that allow it to show plot real-time graphs as well as collect log data and do all the things it currently is doing for people, so those who've tried it, without breaking everything. and I'm experimenting a lot with various strategies related to mostly WebSockets and different packages. Way too many servers out there to choose among, but there's a few that have a little longer pedigree than others. Anyway, well, I sent an email out to the list that was detailing what I did today, so was doing so. If anyone has any interest in it, it's there. That's really all I remember. I know I've been staying busy, but that's it for now.
Okay. Next on the list is Dev, KC3 PVE. Go ahead, Dev.
Hello, good afternoon, everyone. Good evening, everyone. So today we started the CDR workshop. It's an annual NSF funded workshop, which is focused for the undergraduate beginning researchers and which contains many good lectures. So we started with a good spirit today in the virtual mode. So that's the new thing. Thank you.
Well, fine business. And next on the list is David McGaw. Go ahead, David.
Hello, everyone. Not a whole lot to report, but we're working on I'm working on a power system for the Korean Dago station. Hopefully you're going to get deployed. Time is short, but hopefully we'll get that out and have a grape along with it. And more shall be revealed. Back to Net.
Well, fine business. And next on the list is David KEAPEQEP. Sorry. Go ahead, David.
Well, hello, everyone. I'm here mostly to make sure there are a critical mass of Davids on.
Yes.
But I'm mostly here to listen. I sent a message to, well, some listserv. I'm not sure which one, about a magnetometer board, and Jules got back to me, and he's got a spare one, so he's going to send that. And I've got the part from PNI coming tomorrow, as well as the GPS oscillator for the grape, and based on some tests using a tiny SA to inject a 10 megahertz signal, I think the grape may be working. It hasn't let any smoke out, and things seem reasonable. So that's the excitement here.
Well, very good. Sounds like you're making progress. Next on the list, we have Gary, AF8A. Go ahead, Gary.
Yeah, good evening, everyone. Not much to report project-wise here. Basically, just starting to get ready for field day, getting an old laptop up and running with N1MM and WSJT, and starting to get things ready to go for this weekend. So if I don't see everyone, hope everyone has a good field day. Back to Net.
Fine business. And next on the list is Hyoman, KD2MCR. Go ahead, Hyoman.
Hey, good evening, everyone. Not so much to report. I'm slowly working on the documentation for the magnetometer instruction, which will be posted on the website so that people can read it anytime they want. And just like Dave McGaw mentioned, also we are preparing for deployment of the autonomous platform system that can support a couple of scientific instruments in the Antarctic, among which the HAMSI grape system will be planned. So that's a good opportunity for us to make our instrument used by other community and make them aware of our activity as well. So I'm looking forward to that. Other than that, I have not so much to report. Back to Net.
Well, fine business. And next on the list is James, KD4DSG. Go ahead, James.
I think I got it there. Good evening, all. Listening in as usual. Just wanted to pass along some information. I found a new Raspberry Pi SDR hat. I posted it in the chat. It's not even available yet. It's going up on a crowdfunding site, but it's completely open source. Goes to 6 gigahertz and it plugs into the GPIO. It looks interesting, but no pricing yet at all. They haven't put it up. So with that, back to the net.
Well, fine business. And let's see. Next on the list is Jay, WB8SBI. Go ahead, Jay.
Yeah, good evening, everybody. Not a whole lot new here. My laptop, which I am communicating with you now, is in the process of failing. Some really weird random failures. Fortunately, I have a new one, so a new Dell. So now I'm in the process of transferring things over from this one to my new one and commissioning it up. Then just getting ready for field day, and otherwise, not a whole heck of a lot new to report. 7-3 to everybody, and good luck in the contest.
Well, fine business. And next on the list is Jim, 7J1. It keeps bouncing. AJH. Sorry. Go ahead, Jim.
Yeah, good morning, everyone. Just listening from the office. Thanks.
Okay, fine business. And next on the list is the other Jim, K4SBSEs. Go ahead, Jim.
Good evening. Well, a little bit of egg on my face today. We finally got a question on the Grape One posted on the reflector today, and Nathaniel answered it, and then I decided to jump in with a little answer too. And in researching it, I pulled up my record of the same date, and which was last Sunday, and lo and behold, I am shocked to find out that I've had a failure that I didn't realize I'd had. So I'm troubleshooting that now and trying to figure out what has failed in my grape setup. So I haven't found it yet, but I just got started on it a few minutes before I started on this call this evening. So I'm going to have to troubleshoot that, and hopefully I'll get it working again sometime tomorrow. Back to net.
Well, fine business. And next on the list is Jonathan, KC3EEY. Go ahead, Jonathan.
Hi, everybody. I've been working on my test box. I realized that all the jacks that I had planned for this test box seemed to be too much for the enclosure, so I'm having trouble trying to maximize space and making everything fit. But I should be able to fit everything. So what's it's gonna output power to the VLF preamp, and it'll accept its audio signal. It's going to have a earth ground terminal, headphone output with volume control, and switch to turn it on and off, a toggle switch to switch the audio feed from the headphone amplifier, or an RCA jack for external connection to connect it to a computer. I'm going to add it's going to run on two batteries and the DC-DC converter. And what it's going to do, it's going to be able to, I could test the VLF preamp using headphones in the field, and I can make sure that it works. So I'm currently trying to do the mechanical layout, and it's coming together. I just got to put some more jacks in and make sure everything fits. and order some more hardware, some spacers and number 4 screws and nuts. Other than that, I don't have anything to report. Back to the net.
Well, fine business. Now I noticed Bill N8ET jumped in there. So go ahead, Bill.
Nothing to report here. Been busy up at the boat and just got back and got some health problems I got to take care of. So we'll just sit and listen tonight. So back to you.
Well, fine business. And next on the list is John KJ6IBP. Go ahead, John. John, are you there?
Oops.
Okay, thank you. And next on the list is Michael AAAK. Go ahead, Michael.
Well, thank you, Dave. Greetings to everyone listening. I think I got my audio issues going or corrected and seem to have a recording going. So that's good news. And back to you, Dave.
Well, fine business. And next on the list, we have Patrick Daly. Go ahead, Patrick.
I'm new to this. I just saw it and thought I'd zoom in and see what it's about. That is it.
Well, welcome. Hopefully you find it interesting. We'll be discussing development of the Tangerine radio system for space weather monitoring, which is largely RF related. So welcome. Okay, next on the list, we have Scotty, WA2 DFI. Go ahead, Scotty.
Okay, so make sure I get myself unmuted. Good evening, everyone, and just spent some time this week getting ready for field day, which looks like it may not happen here because half the state is on fire. So most of the roads going to our field day site are closed. So we may be doing a home station after all here this weekend. So unfortunately, on the SDR front, still doing some more checking of pinouts between the various boards. Everything's looking good so far. Just have a couple issues that we have to deal with on the RF module that I'd like to talk to Tom about on the after period. And our CAD guy is doing a lot of cleanup on the silk screen to make sure we can mostly see the connector names. And there's an awful lot of parts that are clustered together and are small that we're not going to get reference designators on, but we're going to try the best we can to do it. So he's been taking some time to do that. He's also been just doing some cleanup. He's got all the lengths matching in, but we just have to review the area of the Ethernet where we substituted the 7-channel part, the 6-channel part for the 3-channel part, because he rerouted that whole area. So got to go through and do some more checking there. But we're getting to the point where I think by the end of this week, we're going to be done with this. So we'll be at the point where, if we're brave, we can order PC boards, and then we'll just be waiting for the 2 parts that we're missing. And and on that front, my rep has said that the possibilities of us getting some parts of the speed grade we want are about 0. However, he's suggesting that the next up speed grade, which is the industrial temperature -7 part, we asked for a -6. Well, he's claiming that the -6 part industrial is equivalent to a faster part. Normally the I part is a faster speed grade than the C part, commercial temperature range. So he says he might be able to actually get us some I7 parts, which would be a little bit slower rating, but may be fast enough, because the tool is saying that I need an I6 to do the DRAM interface, to meet the timing for the DRAM interface. So we'll see how far off it gets when we plug in the parameters for the i7 and see what we can get, because we may not get any i6s for a long time. So anyway, what his thought is, he may be able to get us 10 parts of the i7s in a timely manner, in which case we may be able to build at least 10 data engines. And I was telling him, well, how about if you just get me one of the i6s, because we can build one board and be verifying that while we're waiting for the rest of the parts to come in. So anyway, he's still working that. We won't know for a little while what we're going to get, if we're going to get any FPGAs, and I guess we're waiting for those. So back over to you, Dave.
One question for you, Scotty. I saw something that said that you had temperatures of 118. Is that true?
How do you mean we had temperatures of 118? What, where? Spec temperatures, you mean?
In Phoenix.
Oh, yes. I'm like FPGA temperatures of 118?
No, just the outside temperature in Phoenix.
This week has been awful. It's been 114 or higher every single day. And you just go outside, it's like a wall of heat hits you. And, you know, we're used to heat here, but this is ridiculous. This is, I mean, it's middle June, end of June. That's the way it is. It'll lighten up a little bit. The humidity will go up and the temperatures will go down in July when the weather patterns shift and we get more Gulf air instead of Pacific Northwest air. But yeah, it is hot, and like they say, it's a dry heat. But then my answer is, so's an oven, and it's what it feels like outside. So you just kind of stay inside and wait until evening when it goes down into the 90s, and then that's comfortable.
Yes, sir.
It is, though, to be honest, it is 2% humidity.
Yes,
so
well,
I'm nobody's going to tell you it's comfortable, but it's tolerable.
So
living experience 112 dry heat in Boise, coming home to 98 degrees humid in Boston. I'll take the 112.
Yeah. Well, next on the list, we have Tom in 5EG, and Tom's living in a place where I once worked outside in 110-degree heat for a week, and that was enough for me. Go ahead, Tom.
We're closing in on it. It's supposed to be 106 for field day, so going to be warm. This week, I've got the WX Python app talking to the data engine simulator, bringing up the discovery, configuration, and provisioning channels, and sending the register read-write commands to the data engine simulator. Bill, he's not going to be here tonight, but he's done a lot of work on that, consolidated some of the specs. And I have a couple of questions of him. I'm going to wait till he's got some time and we can go over that, but making good progress there. That's about it.
Well, fine business. And I think we've gone through everybody on the list. So we're open for general discussion.
Gotti, could you clarify the dash numbers for the FPGA? Wouldn't a -7 be faster than a -6?
No, the lower the number, the faster it is. So a -8 is the standard slow grade. -7 is faster. -6 is -6
okay.
is the fastest. And then as far as the temperature grades go, they've got an automotive grade, an industrial grade, and a commercial grade.
Right.
And they go in less stringent order in that order. So the automotive is actually the most stringent grade. But typically the way they work it is when they bump up the temperature grade to a higher temperature, like from commercial to industrial,
right,
that actually gives you a speed grade advantage. So an I7 would be equivalent to a C6.
Correct. Right. That's what I was wondering.
Right. And so that's what the rep is saying. Well, you asked for I6s, but you really, you could get I7s, which would be faster than C7s.
Right.
And because apparently he has on his ordering system, he can see all of the
orders. But an I7 is still going to be slower than what we're actually looking for.
It's going to be slower than an I6, right? And because we asked for the fastest speed grade because we need it for the, originally we needed it for the Ethernet, but we also need it for the DDR data coming from the ADCs.
Right.
So faster is better, but you know, what are you going to do if you can't get one?
Right. Well, you can test whatever you can.
You can test
And
with
plus, the speed grades usually are conservative, so it may actually
Right.
work especially if you cool it. Keep
well,
it
and so
cool.
but the idea is being is if we're running in the commercial temperature range anyway, then
Right.
really an i7 will be like a C6, so
Correct.
it will
Right.
be maybe will be fast enough. Anyway,
Yep.
so
Maybe they can find an automotive
yeah,
automotive 7, which
I
would
can't-
be a
I've
nice.
ne- he says he's never even seen that.
Okay.
So
And then
did
that's
they?
the thing. Go ahead.
I was going to ask, do they build these to demand? And that's
what-
why the different.
Well, the thing is that the i7 or the i6 is going to just be a tested selected version. I mean, they don't,
Okay.
it's not a separate assembly line. It's not a separate geometry. It's nothing like that. They pull them off the line. They run their post manufacturing
Okay.
test on them. And then the fast ones get marked i7 and the slower
Okay.
ones get marked i8 and et cetera. And as far as the temperature ranges, I don't know how they actually select those, but what our rep is saying is that he gets to see all of the orders that are placed, all the deliveries. Okay, so he says you are the only one that has i6s on order. Nobody else is using that part. So this is part of the problem is that since we're the only ones and we're using 25 of them, I mean, even though I try to impress upon them the fact that if I can't build prototypes, I'm not going to be building production until I test it. So, I mean, if you want me to buy 1,000, then you better give me 25 so that I can test it. And he understands that, but you know, that the factory has to prioritize what makes profit for them. So, okay, I get it. So, but he says other people apparently are using i7s. So we may be able to kind of skim off a few 10 parts maybe off of one of those orders and actually get some parts, whereas there's no parts to skim off of for ours because we're the only one ordering them. So we can't find some big order and borrow a few because there aren't any. Nobody's ordering those except for us. Isn't that lucky for us?
Is there such a thing as a C6?
That's what I originally ordered.
Ah.
And he says no.
I see.
If you want to 6th grade, you got to buy I only. And he says there's no A6 that he has ever heard of. He doesn't see it on his books. In fact, Dave, the boards that you and I and Nathaniel, you have one of these too.
Right.
Dual port Ethernet board.
Right.
Go look on the part number on that board. And I think, Dave, you did this already. What you're going to see is it's a C6ES. And the E suffix and the ES stands for engineering sample.
Yep.
And so I told my rep, I said, sell me some ESs. If they meet -6 timing, I'm fine with that. Well, apparently Tarasic can get them, but I can't. So he says I can't. They aren't even in his parts book. He can't price them. He can't. And I can't order them. So I don't know how they got -6 ESs, but they did, and we don't, and we can't. So I mean,
generally, engineering samples you don't pay for. They just give them to you out of because you're a nice guy.
I'm just thinking of buying 10 boards and unsoldering the parts and putting them down on our board. You know, I mean, yeah.
Can you do that?
Yeah, it costs more, but you can do that. Yeah.
Are these PGAs or quads?
These are, oh no, it actually won't work because they use a different package type than we do.
Oops.
So, and that's part of the problem is too, we're using a -6 672 ball BGA. Well, as the package size grows and the number of IO pins grows, the capacitance on the pins grows and it gets harder to meet the high speed IO and the high speed rating on the part. So, and I can see what this is. If you go and look in the DRAM example code, the DRAM design, they have a whole document on interfacing to external DRAM memory because they have a soft DRAM controller you can place on the inside the FPGA. So if you look, they have pins in groups that you're not allowed to use for IO. So if you connect the DRAM interface up, the spare pins in that bank, they tell you there's 8 of them in each of the 2 banks that you use that have to be connected to ground. You can't use them for IO. And the only explanation I have for that is they didn't put enough ground pins in the package. And it's different for each package, and it's worse for the bigger packages than it is for the littler packages, because the littler packages don't bond out all of the I/O. The die is the same, and you get 500 I/Os on the die, but if you have a 256-pin package, you can only get like 180 I/Os, and the rest are powers and grounds. Well, on the 672 package, you get all 500, and then you get some powers and grounds, but apparently, if you try to drive all the outputs at the same time, you get a bunch of ground bounce and noise. And so they say, no, you can't do that. You have to take these 16 pins and you have to ground them. And they use that to, number one, reduce the number of I/O pins that switch at the same time because you're using fewer of them. And then you also get more ground pins. And it's pretty bizarre. And even in spite of that, in those banks, depending on the package type, you're only allowed to use a percentage of the remaining I/Os. So they tell you to use 500 I/Os, but good luck trying to use all 500, because it depends on if you're going to drive LEDs with them, that would work. But if you're trying to use it for fast I/O, like talk to a RAM, oh, well, sorry, you can only use 75% of the I/O then. And they actually do that. They rate it 50, 60, 75% of the number of I/Os you can use depending on how many or what you're driving. So what I did is I took all of those extra I/Os that they're telling me I'm not supposed to use, and I use them to drive LEDs, and I use them to do SPI ports, and I use them for slow speed stuff or stuff that happens at initialization, so that normally during the operation of the receiver, those pins are static at one level. So therefore, they don't introduce any noise while you're trying to talk to the DRAM. So I guess we'll see how well that works when we get all the code up and running to verify that we can. And you know, LEDs draw current, but you toggle them at very low speeds. So we'll see see how it works. Sorry for the dissertation.
A little
that is
frustration.
interesting that I presume you have to set those I/Os specifically to connect to ground. But
You
that
have
is interesting.
Yeah, you set them as inputs, and as opposed to something being driven. And then the LEDs, you get to set the drive current. So I'm actually using high efficiency LEDs, and I'm setting the drive current down to like 4 milliamps. So
Well, I'm thinking you set them as inputs or outputs, because if you set them as outputs and then ground them, that's when they're acting as an extra ground.
Well, they haven't told me how to do it yet.
I see.
How to wire it, but
that's very curious though.
What they say on the board, you have to connect them to ground, and then the LEDs, since it's on a 1.5 volt bank, and you can't run an LED at 1.5 volts generally, it's not enough voltage. But you run
only an infrared one.
Well, you run these as open collector outputs, and then you pull them off because all the pins are 3 volt compatible. So that means all of the 1.5 volt bank I/Os, I set them as open drain outputs, and then they sync only, and then the LED's tied to +3. So and then I set the I/O current to 4 milliamps or 2 milliamps, and I use 10 milliamp LEDs, but they're like 100 millicandles. So millicandelas. So you do not want 100 millicandela LEDs on your board. It's like
that'll light your room.
Yeah, we did that with
be able to heat your shack.
I did that with a customer, and he came back and he said, on Rev B, can you make the LEDs dimmer? so we had to change the resistors to make it dimmer. But and, you know,
in fact, what is it? Oh shoot, the other SDR that.
Which one you mean, Hermes? Or
no. Why did I just lose the name of it? The
Red Pitaya, maybe?
Red Pitaya.
Yeah.
That one has some, really bright LEDs.
Yes.
Yeah. Well, we have them too, but we throttle the current back, hopefully, enough so it doesn't blind you.
Yeah, they've made LEDs so much more efficient that the currents you used to set them to will blind you.
Yeah. Well, and LEDs, these are just for debug anyway. There's 16 bicolor LEDs, and they're actually 8 bicolors, so 16 LEDs. So you can get red, green, or amber, or whatever if you turn both on. But they're just for debug anyway, because if you put the thing in a box don't see the LEDs at all anyway. So it won't make any difference. You turn those off when you.
Oh, you're not running fiber optics?
They had enough trouble figuring out how to connect up all the I/O. It's like it took me forever to do this,
You can
and I
make
think
a fiber optic Christmas tree.
yeah.
Dave has a whole bunch of that plastic fiber optic.
Well, I wanted to put some blue LEDs on there, but blue LEDs generally take more than 3 volts. I don't know if they would work at 3 volts or not, but I opted for reds and greens. So yeah, it could be Christmas tree. We should arrange them in a little triangle. So well,
Yeah.
you've seen the Christmas tree, haven't you, made out of LEDs? The guy soldered a bunch of them together, and it clips on a 9-volt battery, and it lights up. And he puts a bunch of them in series, enough of them in series that he doesn't need any limiting resistors. So a little bit hard on the 9-volt battery, but it does light up. Anyway, I have a question for Tom. Hey, Dave, is there a way that you can keep the screen from moving people around at random when people log in? And
I haven't figured out how to do that.
because I'm looking
Nathaniel,
over.
do you know?
No, I'm not sure, but I think you can. I think you can reposition the people on the screen manually.
Yeah.
So I don't know if after you do that, it
figured
locks
that
people in.
They're sorted by name and it's first name. So the first letter of your name. So that's why all the D's are at the top. And
But when I look
Nathaniel
at
is at the top because he's a host.
But when I look at the screen, I see Dave, you're in the upper left, and I'm next, and Nathaniel's next, and then Tom just moved from the second row.
Yeah, because he took his mute off. When you mute, you go down to the bottom of the list, and when you unmute,
Actually, I don't think it's the mute, it's the video. Oh, on the list, yeah. Participants list is another.
I use a participants list to keep track of people.
But yeah, when you if you have your video off and then you turn it on, you jump in the grid as well.
Anyway, so it's like I'm looking at Tom, and all of a sudden I'm looking at a blank. You know, he moved over to there. It's like, wait, where'd he go? Did he leave?
Yes.
Anyway,
and this was a real problem when we were doing like DCC because we had 200 of these.
Yeah, and all of a sudden the guy went to like 5 screens down, right?
Yeah, and you could say, well, is so-and-so here? You say, I have no idea.
Yeah, that's the problem.
So anyway, Tom, I have a question on the sync line from the ADC. I couldn't really figure out what that was for and whether we're going to be using it. Does you have any insight into that?
Oh, gosh. It's been at least a year since I looked at that. I think I've got to remember there is a divider on the part. I think it's a clock divider, and I think sync allows you to lock a couple of chips together. I'm going to have to go back and look at that.
Yeah, because it says only slave mode only. And so then I did a Google search for the word slave, and it appears only 3 times. 2 times where it says slave mode only, and 1 time where it's it describes a register operation. It says synchronously transfers data from the master shift register to the slave, which I don't think is the same thing as slave mode. So it's not obvious what slave mode is.
Okay, I'm going to have to pull up the data sheets.
Okay, at any rate, the reason is I think we're going to have to clamp that one to 1.8 volts with the diode also.
Okay, what the sync does is there is a divide by 8 on the ADC part where the clock, the 122.88 clock gets divided by 8. And that sync allows you to get the divide by 8s on multiple parts to have their divide by 8 in the same state.
But that would reduce our clock rate because the output of that divide by 8 is the sync is the sample clock, right?
No, It's part of what's called a duty cycle stabilizer. And I'm going to have to go read the data sheet to tell you exactly what it does.
So in any case, we may want to use that function then.
Yeah, I pinned it out on the chance that we might want to tie them between two different receiver modules.
Okay.
But
use it
exactly what it clocks, I'm not sure.
And that's an input to the ADC. And so when we set the port to 2.5 volts, we're going to be able to overdrive that. So we need to clamp that with the diode like we do on the SPI port.
Okay. Yeah,
But-
you can do that the same way.
And by putting like a 680 ohm series resistor in the clamp diode, is that going to really slow the edge down enough to be significant?
On the SPI interface, I don't think it's a problem because we're clocking the SPI at a pretty paltry rate. I've got to go look at the sync pin to see if we even need it and what its speed is. So
Okay.
it's going to take me a minute to look it up.
Yeah, that's okay. I don't need an answer right now. I was just curious because I didn't seem to find it in the data sheet. And the other question is on the three SPI pins, the two of them are inputs. The clock and the select are inputs from the FPGA.
Yeah.
And we can clamp those with the diodes as you suggest to prevent overvoltage. The bidirectional pin coming back, we'd have to clamp that with the same kind of circuit, but it's a bidirectional pin. And unfortunately, since it's a 1.8 volt pin on the ADC, it can only drive to 1.8, which is not enough for the input of the FPGA that's biased to 2.5 volts.
So it ought to be close to good enough. What's the spec on the part?
I don't know. I've been looking for it. Typically, I figure 1/3 and 2/3 of the voltage. So a third of the 2.5 would be about 0.8, and 2/3 would be 1.6. So yeah, just squeak by just enough to get the.
Yeah, but it's a pretty slow interface. You'll have to go look that up on the FPGA, but you don't need. All you need is the resistor coming from the FPGA and the clamp diode. You don't need another resistor going back the other way.
Right. But the problem is, so I got to protect the ADC from overvoltage, and that's what the clamp diode does. But that doesn't help me get the higher threshold on the FPGA input. And if I need that, it's going to be problematic on how we're going to make it bidirectional because there's no direction control. So
yeah, one possibility is on the FPGA side of that 680 ohm resistor, put just a little bit of pull-up resistance, and that will pull up the logic 1 threshold. It'll also pull up the logic 0 threshold, but you're so far down below what the FPGA's trigger point is that you ought to be able to center it up with, 3K or 4K of pull-up resistance.
Well, what I was thinking we could do is if we pulled up we could use program the FPGA to be open. Okay, that only works going outbound. We'd have to, if we can set the ADC up so that it is open drain, I can pull it up on the FPGA side to whatever I need.
Yeah, but you don't need to worry that. That 680 ohm resistor will limit. And if you put on the FPGA side of that resistor, put up, 4.7K, 6.8K or something. You'll add a couple of hundred, you'll level shift up a couple hundred millivolts. The logic 0 will still be well within spec, and that'll bump up the logic 1 a little bit.
Good, that'll work. Thanks.
Yeah.
Okay. That's all I needed from Tom. Thanks. That will fix the problem. And we won't have to use a level translator.
Yay.
Yay. But I'm still going to have to use a 1.8 volt regulator on the board because the VCCIO that I supply to you is going to be 2.5, which is not going to work for the VDDIO for the ADC. So we're going to have to put an LDO 1.8 volter on the receiver and regulate it down from 3.3 probably. It's only about 50 mils, I think, from your spec.
Yeah, the part's pretty low power. We already have another one on there to drive the analog 1.8 volts. So
right, I'm gonna
we'll just add another one for the digital.
And I thought I changed the regulator from the big T-pad 3 or 4-pin SOT23. I changed it to the one of those JSON types, the little bitty types, which actually I could fit 2 regulators in the same footprint as that first one.
Okay.
And they're exactly the same part, same die, so it should not affect the anything else.
Yeah, on the digital power for the FPGA, you have to be concerned about the dissipation of the regulator.
But this is only driving the digital I/O for the FPGA or for the ADC and the 1.8 volt analog for the ADC. So
okay.
Yeah, you do have to be careful of that because it's a smaller part, so you need to be careful of heat sinking it right.
Yeah, yeah. So the let me see.
They're both 500 mil regulators though, so I don't.
Yeah, but and the part is drawing, I think, less than 100 mils on all those pins.
Even for the analog?
Yeah, the analog is pretty low. I have to bring up the spec on the part, but if you're dropping from 3.3 down to 1.8, but you got 1.5 volts of drop at 100 mils is 150 milliwatts. So you have a little bit of thermal to worry about.
Yeah, so if I can share my screen here, I will show you, where did it go? This one here. This is the data sheet for the part if I got the right screen.
Okay.
And let's see. No, that's not what I want. I want up here.
It's on page 6.
Page 4.
Oh, okay.
Sure. Yeah, I was on the right page, I think, back here.
Okay. Oh, there it is.
Right there, right?
Yeah.
IDR VDD, 20 million. That's not really much there. And actually, it'll be this one here because we're doing LVDS, right?
Right. That's the and then there is the analog one, which is about just under 100 milliamps.
That is, oh, that's one right here. Yeah, okay.
Right. Yeah, so you
this is the one that, this is what your current regulator supplies.
Yes.
And this is what you were taking off of the pin on the connector, right?
Yeah, I don't remember. I think so. I think that's where the 1.8 was coming.
Yeah, that's where it's coming from. So now we'll have 2 separate regulators, preserve the circuitry for this, and then use another regulator for the digital. So we don't get any noise in it.
Yeah, so your small parts just have to be capable of handling 150 milliwatts of power dissipation.
Yeah, and they're typically, let's see, 500 milliamps at your 3 volts. So that's 150 milliwatts, but that's what really going to be dissipating is going to be about 1/5 of that.
Well, yeah, you're not going to exceed current or voltage on the part. You just have to make sure that your printed circuit board copper can pull the heat out of the part.
Right, but it's rated at 150 milliwatts of heat dissipation, and we're going to be producing about 30 milliwatts. So,
well, let's see. On the analog one, if you're feeding it from 3.3 volts, you're going to be dropping it down to 1.8. So that's 1.5 volts at 100 milliamps is 150 milliwatts.
Okay, but it's rated for 500, so it's at that voltage drop that would be rated for more like 450 milliwatts.
Right, but it depends on having enough copper
right.
to pull that heat out.
But they wouldn't rate the part at 500 milliwatts dissipation if I couldn't do it. So if it's impossible.
Right. What they rate the part at is the most impressive heat sink installation of the component you've ever seen in your life.
With 200 CFM of air blowing on it at Arctic temperatures, right?
That's exactly right.
Yeah.
So just check it out before you do it.
Yeah, and we'll do that. We'll design it to run in Phoenix in the daytime outside.
Yes.
Okay, there you go. There you go. If it can handle that, it can handle most anything.
Yeah.
Hey, did you see where the Starlink dishes have been failing in Phoenix?
No.
Yeah, over temp.
I'm not surprised.
They have a 50C cutoff.
50C, we can get 50C ambient out here.
Okay, let me go look at the sync pin and get back to you.
Okay, sounds good. Thanks. I cannot stop sharing this now.
I have a quick question for Dave Witten or Dave Larson.
Yeah.
What's the minimum Raspberry Pi needed for the magnetometers?
I'd say a Raspberry Pi 3.
A Raspberry Pi 3. Okay. So if I have a Raspberry Pi 3 sitting in my garage doing nothing, there's no reason for me to buy anything better.
No.
I don't know. I don't know of any reason.
No.
I have-
Why would a two not work? It's not working very hard.
But I was just not sure that they're completely how,
Yeah, but
how
I don't know
different
if
they
So
are.
run it on it.
I don't know if anybody's been testing on it too. Maybe Jules.
From what I know, the 3s and the 4s and the 0s are electric. Isn't that right? Electrically the most alike. The 1s and the 2s are different.
And our magnetometer is the size of a 0, so it'd be cool to see if it would actually work with a Pi 0.
Scotty,
yeah,
I wanted to ask if that design you were working on last week, the layout of the board is anywhere where it can be, where I can look at it and get the measurements off of it.
It's nowhere, but I can send it to you.
That would be really appreciated.
Remember, this is all preliminary. This is just what I've put in. This is not what the CAD guys made.
Okay, well.
So this is in other words, this is what I'm going to ask him for. What I'm actually going to get should be the same, but it isn't necessarily, if you know what I mean.
What I care about is where the holes are. So I don't think those are too.
Well, let me show you what the latest one is, and
as far as the Pis go, can a Pi 4 run the magnetometer and grape at the same time, or do you need separate Pis for that?
Should be able to do both because the mag is not a heavy load on it.
I don't think there are any conflicting use of I/O or anything. I know in the grape,
grape isn't using I²C.
Well, according to John McGibbon, we designed it so that they would both run at the same time. But I don't know that anybody's actually tried that.
The next version, he's planning to do it, is my understanding.
Well, the electrical of the next version and the ones that everybody has is the same.
Is it? Okay.
I mean, it's a subset because we actually remove the interrupt lines on the newer one and we don't use them on the one that you have. So it should be the same.
Yeah, that's
theoretically.
So the answer is probably.
Yeah. So
we need a guinea pig to try it.
I mean, well, I hopefully by the end of the week, I'll have both running or not running or smoking. So I'll find out.
Yeah. No, we have Raspberry Pi 3s doing heavy FFTs constantly. And so there's a lot of computing power there.
Theoretically, the difference between theory and practice is nothing, right? Theoretically.
Right.
Yes.
Okay, Scotty, on the sync pin. It's a very high speed pin. It needs 0.24 nanosecond setup and 0.4 nanosecond hold time against the clock. But my guess is we don't need to use it.
Okay.
What it does is it makes sure that the A to D converters in multiple different chips on multiple different boards are synced so that if you need to sample the analog input on exactly the same 122 meg clock edge, that you can get those clock edges precisely aligned on all of the parts. Otherwise, you could have a couple of 122 meg clock edge differences between different receiver modules.
But isn't
So-
that kind of what we want to do with, if we put two two boards, one in each slot?
That may be quite a bit more accuracy than we need, but.
No, that is required.
That is required.
You would, yeah, you would do need to do that.
So you need less than 8 nanoseconds coherence on.
Yeah, that
receivers.
throws it all off. No, you have to have it simultaneous.
Okay, so you're not going to be able to use the series resistor and a Schottky diode on that input.
Yeah, the trouble is most level translators are, a couple of nanoseconds, which is bad.
Right. Well, you have to have that thing precisely aligned against the 122.88 clock. Very precisely aligned.
Well, and I can do that in the FPGA. I can make it like a source synchronous, but once you feed it through a level translator, it's not going to be source synchronous anymore. Right? If a couple of 3 nanoseconds of delay is going to skew it off from the clock.
Okay, let me think about it. There may be a solution. Let me think about it.
Okay, and I'm thinking, yeah, because if we just connected it up, does it matter if we could maybe sync up one edge of it without syncing the other edge up?
Yeah, the data sheet shows it has to be, it's got set up in hold times against one of the clock edges.
Okay, which edge of the sync?
The sync is a full period digital signal, and the sync is sampled by the high-speed clock. So it's got set up in hold time against the 122.88 clock.
Okay, but it's normally high and then it goes low to indicate sync, or the other way around. So it would be like
it's an input to the part.
Right. So when we drive it, we're going to drive it.
We have to drive it. We have to drive it before the rising edge of clock and drop it after the rising edge of clock.
Okay. I'm trying to think how we might be able to shift it around so that we could use the FPGA to move it so that we could align it.
Yeah. So we're probably going to require a level translator on that. And
Yeah.
if your FPGA has timing adjust, then we can do it that way.
Yeah, the problem is that yeah, okay. The problem is that it's not really a periodic signal, right? It's a one-shot signal.
It is 1 out of every 8 clock periods or a one-time event. You can program how you want it to behave using the SPI register.
Okay, because if we made it 1 out of 8, then we could move it around such that both boards would receive it on the same clock edge, but you wouldn't know which one it is, but it would be the same one. So that would work.
Yeah, but when I say 1 out of 8, I don't mean divide by 8. I mean active 1, inactive 7, active 1, inactive 7 clock periods.
Right. But because typically what would happen is it would be a divide output off the clock. And then if you run it through a DLL, you would shift it so that you could line the edges up with the clock exactly.
Okay.
As long as you would get 1 out every 8 clocks, then.
Yeah. You can also make it a one-time deal and keep your fingers crossed that all the dividers on all the modules stay locked up.
The trouble with a one-time deal is that the DLL won't do that. Because it's going to create a clock train from another clock train, and it might be shifted an extra clock, but that's okay if both ADC boards get the same thing lined up with the clock. It doesn't matter which edge it is, which of the 8 edges it is.
With any practical logic, it's just telling you want it to change on the falling edge of the clock, so it'll be set up for the rising edge.
Yeah, I believe,
because it's just this narrow window that it's looking at, and you can change it anywhere outside of that.
It is, yeah, it is. It's active on the right. Scotty, put up page 10 of your data sheet, figure 5.
Okay, 1 second. Of course, I
Yeah,
had.
that's what I'm looking at. And of course, the numbers above it are, as you say, 0.24 setup time, 0.4 hold time. That's just the window that it's looking at, and you can change it anywhere outside of that.
Yeah, well, yeah, what it's being sampled by the rising edge of clock.
Right. So
Right.
generally what we would do is change it on the falling edge and just make sure that propagation delays are such that it sets up for the rising edge.
Correct.
And you've got 8 nanoseconds to do it.
That's right.
Yeah, 8 nanoseconds to get through the FPGA, out the connector, back in the connector, and meet the setup time of the rising edge.
No
Because
problem.
remember, the clock is not generated by the FPGA, it's generated by the clock module. The FPGA gets a synchronous one. So I think we could do this because we could make we could delay the internal clock from the clock module inside the FPGA such that the generation of this sync would be from that clock and we could line the edges up. I think it's doable. Might be difficult, but we could do it.
Yeah, I think, as long as you can control the timing within a few nanoseconds, like within 4 nanoseconds.
Let me see. Let me see what I can find with level translators. I may be able to find a very close to 1 to 1.5 nanosecond level translator, which would be fast enough.
Yeah. So it may not be that huge of an issue.
But we certainly can't do it with a resistor and a clamp diode, that's for sure.
No. That would slow it down way too much.
Way too much. So, okay, thanks, Tom. We'll take a look at that. And
you could do it with perhaps a delay, though. That's not.
It's a level problem, is what I have, because FPGA is at 2.5 volts and the ADC is at 1.8, and the ADC says absolutely not more than 2 volts, otherwise you burn me up. And I can't do that with the FPGA because we have to set the FPGA VCCIO to 2.5 to talk LVDS. We have to.
Yeah, well, you could do it with a capacitance compensated divider. Put a little capacitance around it to speed it up, and then it'd probably be okay.
Yeah. Or maybe an active level translator that's
right. But level translators used in this application are going to be sub-nanosecond.
Yeah, which would be fine.
Yeah, right. The level translators can work on everything except the bidirectional SPI pin.
Right. But like you said, the diode and the resistor work fine on a SPI port since they're running at 100 kilohertz or 400 kilohertz.
Right. So
that's a whole different animal.
So I think the Schottky clamp and the series limiting resistor and the slight pull-up tweak will work fine for those.
Yeah,
that works under that. Yeah.
Okay, and then let's see. I was going to get back with Dave on the too many projects open at the same time, One second here.
This is Witten with the board.
Yes, with the magnetometer, he was looking for the dimensions of the holes. And this is over here. Now, let's try it again.
Do you ever have dreams at night where you're looking for files on a computer and you just can't find them?
All the time. And then I wake up and go sit in front of the computer and my dream.
How about dreams of laying out boards?
Yeah, I definitely have had those.
Then when I was learning C++, how about object-oriented dreams?
Oh
God.
I've had lots of coding dreams and data analysis.
Oh my
This is what Dave needs right there.
Okay, but remember, this is what I'm asking for. This is not what the CAD guy's going to give me. So he may come back and say, this tab's too narrow, or you can't get them that close to the edge. Although I'm not putting them any closer to the edge than they are up here. So I don't see why it should be any problem at all.
Well,
the phrase we have around here is you can't get that from here.
Well, that's fine. If I just get too burnt out on what I'm doing right now, which is feels like it's creeping up on me. I can switch to designing those little plastic things. And, oh, that's right. That's what else I did. But I can design some plastic ends that are closer to what they may be in the end. And then I can take that, and if something shifts a little, well, for one thing, there's some slop in them anyway, and I can adjust them later, but I'll have most of the work done.
Okay, and keep in mind too, this fan connector is a right angle one with the pins pointing out toward the edge of the board.
Okay.
So it will need clearance here on the part. If you're going to run, well, actually, I take that back. It won't, because you're not going to ever run a fan when you're using your brackets, right?
I should think not.
Yeah, I hope not.
Yeah.
Only when it's on the Raspberry Pi. That's what that's for, as a fan connector for those who want to run a fan on their Pi.
Right.
It's just
So
a
that's
5-volt
not an
connector. Yeah, and actually, you can actually power the board off of that also, since it connects to the 5-volt bus. But we won't go.
But this is for what's buried in the ground, so that
Right.
we're worrying
So,
about.
in fact, you could leave that connector off for that end.
Would it be possible to just pot this whole board in some kind of electronics potting compound and, epoxy it to a brick and just bury it and have it be fundamentally just waterproof?
It's almost what they do is they slide into a pipe. And yeah, it's not filled with epoxy, but so Dave, you think that the air gives you some more insulation for temperature stability?
Not meaningfully.
Okay.
But on the other hand,
You can stuff it with fiberglass or such, and then you do get meaningful insulation.
So you could take that foam insulation you buy at Home Depot to insulate doors and windows, and just stick a pipe full of it, and then you'd never get it out.
Yeah. That's nasty stuff.
I've already ruined one of them, so you can ruin them.
Yeah, but you submerged it in water, Dave.
I'm gonna leave the worrying about some of these things to those who wish to put them in Antarctica and stuff like that, because we're doing enough bad stuff to them as it is.
So I can send you this drawing, Dave, and
that's all I want. Yeah.
Okay.
Just a little, even a little JPEG of that or something. That'd be.
I'm not worried about Antarctica. I'm worried about Arizona.
Yeah.
Scotty can just put it in his backyard.
There's no magnetism in Arizona anyway.
That's right. The high
it's above the Curie point.
Yeah, right.
Point, so there's nothing. Jeez. Yeah. I've always wondered, how they have propane cylinders and they just set them outside? And what's the critical temperature of propane? I mean, beyond which it won't liquefy anymore?
I don't know.
So if you set one of them big 10-foot tanks out in the sun in Arizona where it gets up to 140, 150 degrees, isn't that just going to raise the pressure to the astronomical levels when all that liquid propane turns to gas because it's too hot?
You may find out.
I think
they put them outside.
Ask one of the propane dealers.
Well, my new house has a propane tank, but we're burying it in the ground, so it should be a lot better. And according to the propane people, you can't detect how much is in the tank by measuring the pressure. You've got to measure the liquid level in the tank, so they have some kind of special gauge that does that. Kind of like a lithium ion battery. You can't measure the voltage to tell what's left in the battery. It's very because it's so little from min to max. So
I thought they usually just weighed the tanks.
Yeah, maybe
the little ones.
It's the little ones anyway.
Yeah, that's
the big ones in your backyard.
You can't do that at your house.
Well, this is like a 10-foot wide one that buries in the ground to supply your whole house. Because we don't have gas at the new location because they're up against the mountain, and that's unreasonable if they won't run a gas line just to my house. I don't know. But they won't, so I have to supply my own.
Well, guys, I need to go, so I'm going to say 73.
I'm gonna say 73 also.
Okay, Dave, me too. See you later.
And Tom, I'd like to sometime probably email, catch up with you on what you've been working on, because it sounds pretty good, and maybe I can do something with some of that too.
Okay, very good. I'll when I've got some code where you can play with it, I'll get it up on GitHub.
Okay.
Thanks, everyone. 73.
73.
Okay.
Good night, everyone.
I'll get that out to you, Dave.
Thank you very much. And 73 to all.
Let's see. Where,
I guess I can stop sharing this here. Okay, now the trick is, can I print one page? Oh, I love it. Oh, that's better. So Dan, are you ready for tomorrow, right?
I'm ready as I'll ever be.
Okay.
So I thought Henry was on vacation this week, but he's actually on vacation next week.
Oh, okay.
So yeah, because I asked him how things are going on vacation. He says, "Oh, that's next week." So I misunderstood.
So we're okay for 10:30, right?
We're okay for 10:30. Yeah, I sent the invite out this afternoon. So once your ZPCI address.
Okay. Let me see if I got it. I did.
Good.
It's a miracle.
Yeah. It happens every once in a while.
Oh, and I got a part status notification from DigiKey on, oh, that's on another part. Never mind.
Oh.
For a different project, but they're telling me the part's going obsolete. Isn't that nice?
Oh no.
And it's interestingly enough, it's the part that we substituted, a part that we couldn't get.
No.
And now they're telling me the new part's obsolete. So frankly, Scarlett, I don't care because I'm not going to use that part anyway when the other one becomes available. Okay, so theoretically now I've got Dave's print for him. Let's see. By golly, it worked. I'm impressed. Okay. All right. Well, I will see you tomorrow, I guess.
Okay, good deal.
Okay. 7-3, everyone.
I went out and walked tonight.
Oh, I cowered inside.
Well, it was mid-80s here. It wasn't real bad.
Mid-80s. Oh.
The sun was down, so it wasn't like being in the
You know what? I should look here and see what it says because it's right now it's 100.
It was 98 in Payson.
It's 106 degrees right now, and it's 7:15.
No, that's not too bad.
Not too bad. Blah. Hey, it's supposed to rain Tuesday night.
All right.
That's not all right. That'll mean the humidity will go up to like 80%.
Yeah.
Well, for 10 minutes until it all burns off, and then it'll be back down.
I did notice that in Payson yesterday, the dew point was 34.
34?
34, yeah.
Yeah, well, it's 40 degrees right now, our dew point.
Oh, okay.
So that's pretty low, but now on Tuesday when it rains, that's not going to be the case.
Yeah, it may not rain though.
It won't. Oh, it'll, you know what it'll do? It'll rain. You get what we call a 4-inch rain, right? That's 4 inches between the raindrops, and it'll be for 10 minutes, and then it'll go away.
Yeah, it might rain up in the clouds, but it's not raining on the ground.
Oh, hey, let me share my screen. Now that everybody's gone, let me share my screen once more and show you. This is really cool. Could you see that?
Yeah.
That is the 3D model of the data engine with
cool.
the RF modules plugged on the back.
Very nice.
So does it come through okay?
Yeah, it comes through great. You can see everything that's going on there.
So these big tall guys here are the two RJ45s. This is the vertically mounted Ethernet or USB 2. The USB 3 is actually, see if I get this right. It's this connector right here underneath the SMA.
Oh, okay, yeah.
That's a USB 3, a micro USB 3. And then these are not correct. These are all SMAs. This one, and this one. But this is a through-hole SMA, and these two are surface mount SMA. So we didn't have enough room back here behind it to put another SMT one in. And he didn't have a 3D model for the SMT ones. So they come out as like pancake looking ones.
Oh, okay.
You can see how they're kind of squashed flat, but they're really supposed to be SMAs.
So can you buy them as SMAs, but with kind of mounting pins that are through-hole?
Yeah, in fact, if you look at this one here, you can see right here the through-hole pins.
Oh, okay.
And so we're going to have to instruct them. We're going to have to instruct the manufacturer to cut the pins off so that they don't interfere with the USB port down here.
Yeah, for sure.
But there's just no other way we could do it.
Yeah.
And there was not enough room, as you can see all the parts right here.
Yeah.
And these are through hole or our end launch off the side of the board. And the problem is that they have, he doesn't show it here, but they actually have a metal piece that comes down and goes underneath.
Oh, okay.
Right, because the board slides into a slot on the SMA connector. And we just have to, this is the clock module right here, and this is an 031 thick board.
Oh, okay, yeah. From there, I can see the connector actually overhangs the board just a little bit.
Yeah, and you can see here's the outline of the board. It goes along right here, down here. So there's the corner cutout right here.
Yeah.
And the leaf board comes down like this and sticks into this is the M2 connector for it. The leaf board is not shown on here. And then all these parts here, these are the 3 power supplies, 1, 2, 3, 4 low voltage power supplies, and the main power supply is up here in the corner. And that's the power in connector. These 4 SMAs are on the RF modules that are behind, plugged on here, and here's the other end of the RF modules with their 140 pin connectors. This is a battery holder. This is a buzzer, which we're probably not going to put on. It'll be a do not install.
Yeah.
Let's see what else. Again, the clock module's right here. And so the big congestion area is along this side of the board. And fitting the clock module in between the Ethernet, the USB 2 and the board. That was a limiting factor. Okay, we couldn't go any further north than that connector, and then we have a header here, and then we got the leaf board that cuts the corner out, so we had to chop the corner out of the clock module, and then we come back down here, and if I can get it, it's all blue, so you can see that this is the GPS right here, and then if you can look underneath, you see this blue down here.
Yeah.
That's the alternate GPS.
Oh, okay.
So only one of those 2 will be populated.
Yeah.
And one of them is a lot thinner than the other. So we put the fat one on top and the thin one on the bottom, and we have just enough room that we can clear the data engine, and he did a keep out underneath all that to keep the parts out from under the GPS so that it'll fit. It's really nasty because you got to marry them together and then verify you don't have any conflicts that try to occupy the same space.
Yeah.
Dave says this is the hardest board he's worked on in about 2 years. So I don't know if that's a good sign or not. I mean, I'm glad I have him as our CAD guy, but you know, that it's scary when he tells you your board is complicated and the hardest one he's worked on. It's like, ugh. This is the fan connector over here, by the way.
Oh, okay.
And I think these are jumpers for configuration for just debug IO. And then this is the byte blaster header, the configuration header right here.
Oh, okay.
And there's another couple pins somewhere. I don't see them on here, but they are for 1, 2, 3, 4, 5. Oh, it's combined in this header, I guess, because we have 5 jumper straps that we can use for configuration settings that the FPGA can read.
Yeah.
So anyway,
why would you use jumpers like that instead of a little switch?
I hate switches and jumpers. This is a 9-cent part.
Oh,
So
yeah, switches are obviously more expensive and
yeah, and
probably more prone to failure.
probably we won't even use this. I mean, I had the extra IO, so I ran it out to a header so that we could.
Yeah.
I mean, a lot of this stuff I don't really have a use for. It's just like, well, okay, we did it on the Hermes, so let's, or one of the other boards we did. Like this buzzer, I stole this off of the Lime SDR.
Oh, okay.
This idea, I don't even know what we'd use a buzzer for, but they had one, so I put one on there.
Okay.
But we'll just leave it off, you know, it's there if we need it, and we generally won't use it. And then this is the real-time clock, I think, right in here that this battery runs. And I debated whether to put that on there because I think the Pi has a real-time clock, but it's an option, right?
Yeah.
So you have to buy it and hook it on, and it runs on the I2C or something.
Yeah, it actually hooks onto the GPIO header.
Okay.
And it's pins, I think 1, 3, 4, and 6 or something like that. It's
3 and
maybe it's 1, 3, 5, and 7.
3 and 5 is I2C.
Okay, well
And one I think is 5 volts.
There are 5 pins in a row.
Okay.
Actually, I've got one here.
Yeah. So I think 1 is 5 volts and 7 is ground, maybe, or 9 is ground.
Yeah. Maybe it's 2, 4, 6, and 8. I'm not sure, but this is what it looks like. You can see
wow, it's microscopic, and it plugs right on the header.
Yeah, it's this black piece on here is a little connector. It's like a 4-pin connector, and there's not much on it. There's a battery, which is a little thing that's inside the yellow circle.
Yeah.
And then the rest of it is just an IC and a couple of resistors, looks like, and a capacitor.
Well, at any rate, I put that kind of circuitry on here because the entire circuitry, if you use a battery holder, which is just a clip, and the crystal and the real-time clock, it's under $2 for all the parts.
Yeah, these are really inexpensive. You can buy, this is, I think, the latest and greatest chip. There are 4 or 5 different kinds of chips for real-time clocks. But I think I paid like $5 or something like that for 4 of these.
So it's hardly worth even putting it on our board for the.
Yeah, the only problem is that if you have an enclosure, the enclosures, well, it won't be a problem with this board, but on a lot of boards, the enclosure doesn't clear the header well enough that you could stick this in.
Oh. So then you can't use any kind of enclosure that's stock.
Exactly. You can't use a ready-made enclosure. You have to use something special.
Yeah.
Yeah, because I would have liked to, I mean, I have like a fork enclosure for my Raspberry Pi 4, and that's what I really bought this for. But I can't use it on the 4 because the enclosure doesn't allow it to fit in.
Yeah. Well, so what I'm envisioning for an enclosure for this is a clamshell with a pedestal inside for these two parts. This is the memory and this is the FPGA. And then it would need on the back, the ADC is this guy right here.
Yeah.
And I'm not sure what these are. Oh, these are the preamps. So these are the only parts that draw any kind of current. So you could theoretically put a pedestal here, but then this is the connector for the optional filter. So you're going to have to leave that open so you can, an opening here for you to be able to plug that in if you want to be able to use it.
Yeah.
So anyway, and these are the relays up here. And these select the noise source or the attenuators for the RF module. And then this is a power header if you want to run preamp on these headers here. This jumper is the power in. Normally you do not want to, this connects the grounds, I should say.
Yeah.
Normally you don't want to connect any grounds on the through filters. You want it to be isolated. And I take that back. You want obviously you got to have ground on it, but you don't want that ground connected to power ground.
Yeah.
And so it's an isolated ground. But if you want to put a preamp on there, you can't get power to it because the ground has to be connected together.
Yeah.
So that's what these jumpers do here. So allow you to connect power, feed power to the filter board so that you can put a preamp on there if you wanted to. So I think it's looking pretty good as far as how it's going to all fit together.
Well, there's no reason you couldn't do like a 3D printed enclosure for that.
No, except that you want it out of metal if you're going to heat sink it.
Well, yeah, that's probably true. Well, it's interesting. Yeah.
I mean, what we could do is we could put stick-on heat sinks on these two parts and just run a fan. We have a fan connector, so we can do that.
Yeah.
And actually what you could do, interestingly enough, is if you were to use a leaf module with a fan on it that blew down through the board, it would come out and go right across these two parts. So you could make a leaf module that had a fan on it, and that's all its function would be is to.
Well, there is like Pi Moroni does like a little fan that's set up like that.
So is it a Raspberry Pi hat with a fan on it?
Yeah, yeah.
Yeah. You could do that, and you don't even need this connector here. You could run it right off of the Pi.
Yeah.
Because I put some additional voltages on this connector, so if you wanted to build something that used 12 volts, you have it available on that connector. So you have more power.
Yeah, more power, more happy.
And then the idea was I kept these down as low as I could so that this area here is for the VLF module front end to keep it away from the power supplies. Be up near the connector here. And then as soon as you go digital, all the rest of this down here to the connector, it doesn't matter because you can pick up any noise. So being digital. Anyway, that's it. Just thought it was sitting up here on my screen, and I should have brought this up for everybody to look at, but
yeah, people would have been excited about that.
Yeah, it's kind of this is amazing. This is an eDrawings viewer.
Yeah.
And so Dave made these from the CAD program. So all of these are actual heights of components that when I built the parts, I put them in. So they're black boxes, so like that's why these come out looking so weird.
It's like an envelope shape.
An envelope shape, right. But so you can see how when you look in here, you can see the parts that are on the back of one and on the front of the other. So ideally, I mean, you can look through here and you can see that there's nothing that exceeds the half, the center line between the two boards, except up here, you may have a problem. So what I did is I actually made a list of all of the parts that are on the board that are taller than half the gap. And then we're going to check each one individually to make sure that there's nothing above it, if it's on the top, or below it if it's on the bottom, whatever, other way around. I can't believe how tall this Ethernet stack thing is.
Well, compared to other stuff, I mean, RJ45s are pretty massive connectors.
Yeah.
It's considered.
But if we had only one, then it would be, that would be the tallest part along with the USB 2.
Yeah.
Well, next week I'll show this off and it'll be completed.
Yeah.
So it'll be something for everybody to look at.
Yep.
All right.
Okay, talk to you later and see you tomorrow.
Go outside and burn my brain out.
All right. Gotta go mow the lawn.
Oh yeah, it needs it too, and I just haven't been brave enough to do it. Well, we got irrigation Sunday, so I have to wait probably till Wednesday.
Oh yeah.
And it's supposed to
off by then.
It's supposed to be cloudy Tuesday because it's supposed to rain. So it's only going to be like 107 or something. So that'll be the day that I'll go out and mow.
Yeah.
I think I'll hire Oliver Douglas to come out and mow my lawn with his tractor.
Good idea.
All right. See you later.
Okay. Night.
Bye, everyone.